Here we're doing a problem from your textbook, and we're starting off with a situation where a watermelon's on a scale. I should have put the grid over here, but let's draw a free body diagram and start by drawing force of gravity. Okay, now because we're assuming that it's just sitting there on the scale, then we're going to say acceleration is 0. So that would mean that the spring, oops, that's pretty sloppy, the spring force is going to cancel, right, with the force of gravity in order to keep it from accelerating. So again, we're just like when we drew our free body diagrams on that worksheet earlier, we know that it's accelerating. It's not accelerating because all the forces are canceling. So now that we know that, we're really basing that on the Newton's second law, which would be this version, that the net force is equal to mass times acceleration, or working backwards from the other, acceleration is net force over mass, right? But the other definition of net force is that net force is the sum of all forces. And so that's how we decided that these two forces should cancel each other, because we know that they add to 0. Okay, so now I don't have a formula for spring force. We never went over that, right? But I do have a formula for force of gravity, and that's what's going to help me solve for the reading on the scale, because what they're asking for is the spring force. But I know that all the forces add to 0. In other words, I know they cancel. So I'm going to be kind of anal here and write this out like an equation. But that's basically what I'm saying. When I say they cancel, I know they add to 0, and like one of them is going to be positive and one of them is going to be negative. So the formula for Fg that we learned is negative mg. And then if I move that to the other side, so I'm going to add mg to both sides, then I'm going to get positive mg is equal to the spring force. So then I would just do 4 kilograms multiplied by 9.8 meters per second squared, and that will tell me what the spring force is. And when I do that on my calculator, I only keep 2 sig figs, so that's, I think I get 39 newtons. Okay, and then I'm done. So that's the routine here, is that I can use one force on the diagram to solve for a different one if I know what the net force is.